Well, so in this particular video, I'm going to go over adding and subtracting fractions when you have a common denominator and when you don't. There are parts of this that you may not want to watch, so just scoot to the part that you need, and I'll give you some markers to tell you what to fast forward to if you don't need the information. There's also this imported funny, so there's some places where I'm going to have to handwrite that would have normally been typed. So if you have a common denominator, these are like terms. So the denominator is the same. And when we're adding fractions, or subtracting fractions, we're just count how many fifths we have. So all you're doing is adding 1 plus 3. You have 4 whats? You have 4 fifths. So you're going to add the top numbers, and then you're going to put it over the denominator. So 1 fifth plus 3 fifths is 4 fifths. Sometimes you might end up with a mixed number, and I just like to change them so they're all the same. So since they already have a common denominator, I'm going to change this mixed number to 2 times 5 is 10, 10 plus 1 is 11, and you end up with 12 fifths. If you had done 2 and 2 fifths, that's fine. But for our purposes in algebra, it's almost always easier to have it in fraction form, so leaving it there is fine. And then here you actually do need to change it to from a mixed number to a fraction. Same thing, 2 times 5 is 10, plus 1 is 11 fifths, minus 2 fifths. So the key idea is, if you have a common denominator, just adding or subtracting the top numbers, because the top numbers tell you how much of the fifths you have. Now, if there's not a common denominator, the first thing you do is find one that works for the two fractions you're adding. Then this step right here, we have to make equivalent fractions. And we're going to use our giant 1 for that, like we were using with our simplifying. And then all you have to do is go back what we did in the first 3 slides, which is just to add the numerators and then put it over the denominator. So this is one of the ones that came out funny. So I am going to, let's see what I'm going to do. So this came out funny, so I'm just going to ask you to pay attention to the 2 fifths and the 3 sevenths. To find a common denominator, if you already have some strategies, go ahead and figure what common denominator you would use. And if you don't have strategies, I'm going to give you one using a multiplication chart in a second. So 2 fifths and 3 sevenths, we could just start thinking about the multiples of 5, right? Blah, 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 25, 30, 35, and the multiples of 7, 7, 14, 21. First thing they have in common is 35. So that's a good common denominator for 2 fifths and 3 sevenths. If you are someone who can do 6 and 8 and 5 and 50ths, go ahead and figure out the common denominators that you would use. For the rest of you, I'm going to explain how to use a multiplication chart to find the common denominators in the next couple of slides. So if you are someone who got 35 and 24 and 50 as the 3 common denominators for the 3 different problem sets, then you can scoot yourself forward till you see a big star. Here we're going to use our multiplication chart to find a common denominator. And so we're going to look at our 7s. I'm going to go ahead and highlight our 7s going across, right? Oop, that's not what I meant to do. That's interesting. Highlight our 7s. And then we're going to go ahead and go in the other direction and highlight our 5s and see where they intersect. And they're going to intersect right there at 35. So we have a common denominator of 35. We're going to do that again with the next one. So once again, it's fairly easy. I'm making a list of multiples: 6, 12, 18, etc., and 8, 16, etc. But if you've got your multiplication chart handy, you can go ahead and use 6, 12, 18, 24, 30, 36, etc. And then do your 8s. 8, 16, 24, 32. Oh, where do they intersect? Right here at 6 times 8, which is 48. Or you can look where the first time that they have the same thing in common, which is 24 and 24. So you could use 48 or you could use 24 because the math will be easier in the long run. You won't have to simplify. Remember, once we get our common denominators, we're going to go ahead and start setting up so we can create our equivalent fractions. Now with 1/5 and 1/50th, we don't have the multiples of 50, but we can look at our 5s and see that right here, 5 times 10 is 50. So we can go ahead and use 50 as our common denominator. And we can then start the process of using equivalent fractions. So I don't know why when this transferred from the PowerPoint, we ended up with 3 copies of the problem. So once again, I'm going to go ahead and just cross off this and cross off this and point out that 5ths and 7ths right here, the easiest common denominator would be 35. For 6th and 8ths, a good common denominator is either 24 or 48. And a common denominator of 50 works for 5 and 50. Our next step is to create equivalent fractions, and our multiplication chart can help us again also if multiplication is not your strong suit. So we're going to use a giant 1 to help us find our equivalent fractions. And so we're looking to see what we have to multiply 5 by to get to 35. And some of you have those multiplication facts in your heads, and some of you need a little support. So here we go. Here are 5s. Here's 35. 5 times what is 35? 7. So 5 times 7 is 35. So we're going to do the same thing on the top of the bottom. 5 times 7 is 35. 2 times 7 is 14. We're going to continue that process. Well, in this case, it's obvious to see that 5 times 7 is 35, and 7 times 5 is 35. So we're going to go ahead and multiply 3 times 5 is 15. So now we have equivalent fractions with a common denominator. Then all we have to do is add the numerators to find the sum. We're going to continue this process with the other 2 problems. If you're starting to get it, stop the video and do it yourself, and then see if you're getting it right. So here we have 24ths. We're going to look at 6 times what is 24? 6 times 4 is 24. And you can use the multiplication chart to here are 6's, here's 24, and then we scoot all the way up there. It would be 6 times 4. Now since we know that 6 times 4 is 24, then we're going to do the same thing on top that we did on the bottom. 1 times 4 is 4. So 1/6 and 4 24ths are equivalent fractions. They mean the same number, and this looks the strangest 4 ever, so let me erase that. Then we're going to look at 8ths. 8 times what is 24? 8 times 3 is 24. I know that because here's my 8s. 8, 16, 24. Here's 24. Let's scoot up. Here's 8 times 3. So we're going to go ahead and do 3 times 3 is 9. Now we have equivalent fractions with a common denominator, and all we'd have to do is add the 9 plus 4, which we'll do that in the last slide just as a reminder. Last one, go ahead and try it on your own. Stop the video, see what you get, and then I'll walk through it. You probably know this one without using the multiplication chart. 5 times 10 is 50, because a lot of us know our 10s really well. And if you don't, here we go. 5 times what is 50? Oh, there's 50. 5 times 10. And 1 times 10 is 10. 50 times 1 and 1, so that's the same thing. And now we have 10 50ths and 1 50th, and we can go ahead and do our addition. Here we are, weird slide. So I'm just going to stop it, cross all this off, and we're going to go ahead and just do the final addition. So 14 35ths and 15 35ths. We have a common denominator, check. And we have written equivalent fractions, so they are equal to the original fractions we had. So then we go ahead and just add. 14 plus 15 is 29 35ths. 4 24ths and 9 24ths Just add them up. We get 13/24, and since I'm running out of space, 10/50 and 1/50 or 11/50. I specifically didn't require any of these to be simplified because I didn't want to add one more step. But after you're done, you can look to see if there's any common factors you can divide out.